Auzubillahiminashaitanirrajim. Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Yesterday we have discussed the structure of the ovule, and we have seen that an ovule has three important parts, that is base, upper end and stalk. Stalk of the ovule is called funicle, base of the ovule is called claza, and upper end of the ovule is called micropyle or microphylar end. Now we can say the three important parts of an ovule are funicle, that is stalk of the ovule, callosal end, that is basal part of the ovule, and micropylar end, which is characterized by the presence of the micropyle, which is the opening which provides the passage, passage through which pollen tube enters into the ovule. Now, depending upon the relative position of this funicle, micropyle and claza, depending upon the relative position of funicle, that is stalk, micropyle, that is upper end, and the claza, at maturity, we have six types of ovules. Number first is orthotrophs ovule. Number second is anatrophs ovule. Number third is hemianatrophs ovule. Number fourth is camphylotrophs ovule. Number fifth is the amphitrophs ovule. And number sixth is the cercinotrophs ovule. Now we will take off first, that is orthotrophs ovule. This type of ovule is also called straight ovule or upright ovule. Why? Because here the body of the ovule, it is straight or upright with claza, micropyle and funicle in straight line, in single line. That is here, this is the micropyle, claza and stalk. This is funicle, this is claza, and this is micropyle, and they are in straight line, they are in single line. They are arranged in straight line. That is why we call it as straight ovule or upright ovule. And this ovule, it is the characteristic of gymnosperms. Now second type of ovule, that is anatrophs ovule. It is also known as inverted ovule because here the whole body of the ovule is inverted through 180 degrees. And here the whole body of the ovule, it is inverted through 180 degrees, with the result this micropyle, it comes very close to the funicle, and a micropyle comes very close to the funicle. Such a type of ovule, as it is inverted, it is known as anatrophs ovule or inverted ovule, and here the body of the ovule, it is inverted through 180 degrees Celsius, and as a result the micropyle comes very close to the base of the ovule, and this is the most common type of ovule found in angiosperms. That's anatrophs ovule. Now third type, that's hemianatrophs ovule. Here the body of the ovule is turned through 180 degrees Celsius. It was 180 degrees. Here it is turned only 190 degrees. With the result, body of the ovule is turned through 90 degrees and is horizontally placed. Yep side is micropyle, yet claza, yep funicle, and it is horizontally placed. Such a type of ovule is called hemitrophs ovule, while the curvature of the body is only 90 degrees Celsius, and ovule is horizontally placed. Number fourth is camphylotrophs ovule. Here the body of the ovule is curved, but the curvature is less than that of the anatrophs ovule. As such, the micropyle and claza are not in straight line, and the funicle lies at right angles to them. And here curvature takes place, but the curvature is not as we have seen in case of anatrophs ovule. With the result, Chalaza and micropyle, they are not in straight line, but they are not in straight line and the funicle lies at right angles, and this is the micropyle, this is chalaza, and this funicle, it is at right angles. And the ovule in which funicle is right angled to the chalaza, it is called as campylotropes ovule. Number fifth type is ambitropes ovule. Such a type of ovule has a pronounced curvature of the body, and here the body has a pronounced curvature, but what happens here, the embryo sac, which is in the center of the ovule, it also curves. And the body of the ovule has a pronounced curvature, but here this embryo sac also curves. It also curves and gives the shape of horseshoe. Horseshoe shaped. That is such a type of ovule has a pronounced curvature of the body, but here the embryo sac also bends and becomes horseshoe shaped. Here embryo sac becomes horseshoe shaped. Such a type of ovule is called ambitropes ovule. Number sixth type, that is cercinotropes. In this type, the funicle is very long and forms a complete circle around the body of the ovule. And here, if this is the body of the ovule, this is funicle, it is very long and forms a complete circle around the body of the ovule. Such a type of ovule is called cercinotropes ovule. And now we have seen that on the basis of mutual relationship, relative position of funicle, micropyle and chalaza at maturity, we have six types of ovules. Now first, orthotropes ovule, anatropes ovule, hemianatropes ovule, campylotropes ovule, amphitropes ovule and cercinotropes ovule. Orthotropes ovule is known as straight ovule or upright ovule, which is the characteristic of gymnosperms. Anatropes ovule is called inverted ovule, which is the most common type of ovule, and is here the body of the ovule is curved by 180 degrees Celsius. Hemianatropes ovule, here the body is turned through 90 degrees only and is horizontally placed. Number 4 type, campylotropes, here the body of the ovule is curved but the curvature is less than anatropes ovule. As such, the micropyle and the chalaza are not in straight line and the funicle lies at right angles to the chalaza. And in campylotropes ovule, funicle lies at right angles to chalaza. Amphitropes ovule, here the body of the ovule has pronounced curvature, but embryo sac also bends and becomes horseshoe shaped. That means amphitropes ovule is characterized by the presence of horseshoe shaped embryo sac, and it shows the presence of horseshoe shaped embryo sac. Cercinotropes, in this type of ovule, the body, the funicle is very long and forms a complete circle around the body of the ovule. Such a type of ovule is called cercinotropes ovule. This is all for today. Thank you. Assalamu alaikum.